Good evening, Amahle. Good evening, grade 11s. I hope that everyone is well. So, there's a question that Amahle sent to me, and I will quickly go through it so that everyone understands what to do here. So, the question just simply says find the unknown. So, what Amahle has already established is that here we also have the sine rule, right? We have the sine rule, and if I just quickly and look at this diagram here, what can I do? I can quickly notice that I've got D, and D has been mentioned as D1, D2. They've also mentioned F as F1. They've also given me X as well as Y, right? So that means I should also be looking at my angles, right? So for the first one, what I would do is start with D1, right? Because here I've got a triangle, so that means I can find the value of the unknown of D1 using some angles of a triangle. So what can I do there? I can just simply go to my answer sheet. So this is question E, right? I could say E, and then the first thing that I'll be calculating is D1, right? So in order for me to find the value of D1, I'm using some angles of a triangle. So this is what the triangle that I'm looking at is D, E, F, right? D, E, F. Some angles of a triangle, I've got 90 and 60. So I'll simply say um, D1 is equal to 180 degrees, because that's the entirety of a triangle, minus 90 degrees, which is the right angle, minus 60. And then my reason is some angles of a triangle, right? That's the first thing. So my angle of D1 is then equal to, let me just quickly do that in my calculator, 180 minus 90 minus 60, giving me a value of 30 degrees. I'll just write the answers in red. So that's 30 degrees, which is then D1. And then from there, I can then go on and... Can I calculate another angle? Yes, I can. I can calculate the angle of the straight line. Which straight line am I dealing with? The straight line EG, right? So EG can be calculated using straight line rule. And then I'll just create the angle there. So I'll be looking at the angle F1. That's what I would be calculating. So I'll just simply say F1 is equal to, what do I have for a straight line? 180. So I'll say 180 minus the angle there, which is then 60 degrees. And then what's my reason there? Straight line. STR line. Right? And then that angle there is then equal to 120. You can calculate it using your calculator, right? You're more than welcome to do that. I'm using simple maths in my head. So that's 120. So now we already have the angle F1. And then another angle, so this is, let me just write it in there. This is 120 degrees. This angle here was then 30 degrees. And then now we can also calculate D2. How would we then calculate D2? If I look at D2, D2 is this angle here. Let me denote it with a different color. No, I'm looking for a color which can actually show up properly. So this is the angle D. And if I look at D in the triangle, um, DE, DEG, right? So I'm looking at this triangle here. So let me just quickly write it down there. So I'm looking at triangles DEG. If I look at that, I can automatically see that D is the entire angle there, and I have that angle there, and I have that angle there. So that means I can also still use some angles of a triangle, right? So I can then simply say D2 is equal to 180 minus all the angles I have. So the first one that I have is 20 degrees. Another one I have is 90 degrees. And then the last one that I already have is 30 degrees. So D2 is going to be what's left there. So I can say minus 20 degrees, minus 90 degrees, and then finally minus that 30 degrees there. And then what can I say? Sum angles of a triangle, right? Sum angles of a triangle. So my answer there, quickly do it on my calculator. So I'm simply saying 180 minus 20 minus 90. I think there was another angle there, minus 30 degrees, which gives me a final value of D2 equal to 40 degrees, right? So there you've already have how many marks here? You haven't even started to the actual question that is based on what? Based on the sine rule. So you already have how many marks? Got 1 mark there. That includes your reasoning. 1 mark there, 1 mark there. So 3 marks out of what? Out of probably 7 marks, right? This is a 7 mark type question if I just glance at it. So you already have your 3 marks there. And then here you already have your angles. So your angles here, what angles do I have? I've got 30, 40, 90, 60, 120, as well as 20 degrees. That's everything that I have here. So now I can go on and check for my sides. What are the unknown sides that I'm looking for? Let me just increase this. The unknown sides that I'm looking for is my x and my y, right? Now, how many marks are you going to get for these? I would say you would then get 2 marks each, hence the 7 marks. Remember, your angles are your 3 marks, and then 2 marks each, meaning 2 marks for your x, 2 marks for your y. Now, let's make that true. Let's make it true, guys. So here, what am I going to start with? Let me just quickly erase all of this. Oh, no. Okay, I'll rewrite it again. So here we had D1 was 30, 40, 120. No, I want it to be darker. So this is 30, 40, and this is 120 degrees. Okay, that's better. So now I can go on and look at my sides. And then is thinking about the sine rule. Let me add a page there. What does the sine rule say? The sine rule stipulates that it says, given the fact that if you have a side, call it A. Yes, the side A in a triangle over sine the angle is equal to a side B of sine an angle B is equal to C sine of an angle C, right? So that's where it starts. If I can just depict that in a drawing, let me just quickly get a drawing here. It's saying that if I am given A, B, C as angles, obviously the opposite side of A is then what? I'll write it in a different color. A, opposite side of C is small c, opposite side of B is small b. If I'm given the side of A, right, here's my A side here, and then the angle of A, I can say it's then equal to what? So the angle, or the side as well as the angle is equal to what? To the side, the side as well as the angle of the other side, right? For any triangle, it doesn't matter. It can be a right angle triangle, it can be an isosceles triangle, it could be an equilateral triangle, but that is the sine rule, right? Another way to stipulate it, don't get confused. Another way that you can also write this, let me use blue instead, is sine of an angle A over the side of the angle A is equal to the sine of the angle B over the side of B as well as the sine of the angle C over the side of C. So this is interchangeable, right? You can flip it around as long as if you have angles on top or at the bottom, have angles at the bottom, and then the sides on top. And if I've got the angles on top, all my sides should be where? At the bottom. So that's the rule. So let's quickly now go back to our drawing. If I look at my drawing here, what do I have already? Here I've got, I can just mark two things. I'm looking for an angle as well as an opposite side for each of these triangles. So that's what I'm going to look at. Here's my angle, which is 40 watts. What's opposite 40 degrees? My side, 150. EG is equal to 150. And then I go on, let's look at this drawing here. So that means I can't, because I need to find x first in order for me to have what? An angle as well as what? An opposite side of x. So this question is actually following along. So I start with finding x, then I go on to find y. That's why we always say try to go alphabetically in order so that you can be able to do these. So here, let me just quickly check what is my opposite angle to x. My opposite angle is then 20. So x and 20 share the relationship, and then this guy, the 40 and the 40 and the 150 also share a relationship. So I can just simply say, in order for me to find x, I can say, I can even put x on top, right? Remember, x sine who? What's opposite my x? Sine 20, right, is equal to, what do I have here? 40 and 150. So 150 goes on top, 150 over sine 40, right? So now what I can just simply do is cross multiply or move things over the bridge. So x is then equal to 150 over sine 40 times sine 20, and then I can put that in my calculator, and that will then give me an answer. So let's just quickly give that again. So I'm saying the side of 150 over sine 40 multiplied by sine 20. Yes, it's okay, I'm using degrees. So that gives me an x value of 79,813. 79,813. So that's my x value, right? What I'm going to do is I will then say I'll store it. So I'm simply going to say shift store at A, right? Oh, let's just keep it as answer. It's fine. We'll keep it as our answer for now. So that's the value of x. X is then equal to 79,813. Not degrees. Is it in centimeters? Oh, units. Just units. They haven't given us our unit measure, right? And then, now that you've found x, now you can move on to the next part, which is now finding y. So now you have what? You have the side as well as the angle being 90 degrees. And then what are we also looking for? We're looking for y. Y must have a corresponding angle to it. So 30 corresponds with y. So we've got 90 that as well as 30 y. So what I'm going to do is, let's see. What am I looking for? Am I looking for the side or the angle? I'm still looking for the side, so I'll keep my side on top. So I'll just simply say y over sine. Sine who? Let's go back to what corresponds to y. Sine 30. So opposite y is 30 degrees is equal to what? We started with the side, so we start with the side again. The side that I'm talking about is 79,813, which is the value of x, right? It's this value here. So it's going to be 79,813 over sine what? What's opposite that? It's a 90-degree angle. You can just quickly double check that. That's opposite my x. So my final answer, and then say y is then equal to, just simply move this sine 30 over the bridge, 79,813 over sine 90, which is roughly 1 times sine 30. Put that in my calculator. That gives me the side of y. So I've got, this is your answer, previous answer. I'm using previous answer over sine 90 multiplied by sine 30. That gives you a side of 39,906. So 39,906. And then with rounding off grade 10s and 11s, it's really up to you. But I am mostly talking to the grade 11s. I'm not talking to the grade 10s here, because the grade 10s don't do the sine rule. Okay, that's about it for this video. Okay, cheers. Have a good one.